We said a use case needs to comply with 3 factors for AI to be a likely solution. The 3 use cases we're looking at today, they do comply with those 3. This has been shockingly successful. So the same capability plus patience leads to a step change. Hi, this is Carsten from Hacking Matters, where each week we explore developments in cybersecurity. Today we're checking back in on AI and how cyber use cases can be supported with AI. We'll go over 3 AI-supported use cases that work really well in uplifting cybersecurity. Right now it's the middle of 2025, so all of us had about 2 years to play with LLMs and to understand their power and limitations. The initial excitement that LLMs and AI more generally would replace everything we do in cyber, of course, has made room for a more realistic perspective that AI is there to support, to automate, but not necessarily to revolutionize cyber yet. So the 3 use cases we're looking at today, they're making big differences, but not through revolution, but through evolution of established practices. We'll look at 1 use case from security monitoring, 1 use case from application assurance, and 1 use case from auditing. In each of the use cases, we'll notice that AI's superpower is patience. That we could have long achieved those goals if we had been indefinitely patient like AIs are. Before going into the use cases, let's briefly remind ourselves of the framework we established elsewhere to decide whether a use case is primed for AI automation. We said a use case needs to comply with 3 factors for AI to be a likely solution. The first factor was it needs to be a big data problem. If there is just small data, if it's understandable by a human brain with our limited memory capacity, usually we don't need AI to help us with. The second criteria was that there must be non-trivial connections within that data, some hidden structure that on first sight is not necessarily visible, where you have to think about it and evaluate something. And thirdly, if AI comes back with a solution, we should be able to distinguish a correct from a wrong answer. AIs are still not completely reliable, so we can't allow AI to be part of our processes and then through hallucinations to throw us off, right? We need to be able to distinguish those wrong outcomes from good outcomes. Suffice it to say, the 3 use cases we're looking at today, they do comply with those 3. Going straight into the first use case, security monitoring, and specifically user behavior analysis, which was a hype word about 10 years ago, and it's mostly died out because the solutions that were presented to us 10 years ago, while they mostly worked, they created so much noise that it was almost impossible to investigate all the triggers. So what is user behavior analysis? Like the name suggests, you're looking at the actions a user takes in your IT systems, and you try to decide whether these actions are kind of unusual and thereby suspicious and should be investigated. The list of actions that are suspicious is long and includes things like you're uploading a large amount of data to the internet. You're going to a website that you've never been to before. You're working at a time you don't usually work or from a location that you don't usually reside in. You work from a location that is very far away from a location that you were just moments ago. Any of those, of course, would be worth investigating if you have infinite time as the security team. Well, you don't. So you want to see stronger patterns emerge before triggering an investigation. And pattern recognition is exactly what LLMs are very, very good at. Giving an LLM access to the normal usage behavior and then having the LLM contrast that with the current usage behavior allows you to generate very strong alerts, high suspicious events. And unlike before with user behavior analysis, where we had hundreds of investigations per day, now we have maybe 1 or 2 per week that are really worth investigating after the LLM has done the filtering. And the beauty of using LLMs as opposed to more rigid analysis methods is that the LLM sometimes sees patterns that you didn't even think about. So for instance, when we ran our experiments first, we came across one pattern we didn't expect. And that was a user visiting a website in a browser without having a referral. So they didn't click on anything. Somehow, magically, the link opened in the browser. Could have been that the user copy-pasted it in, could have been that they clicked on an email or some chat message and opened it. And both of these cases are suspicious. It could be a hacker in direct control of your computer, or somehow encouraging you to copy-paste something from another source or click on a link. The fact that the action didn't originate in the browser makes this suspicious. And if then some of the other suspicion triggers factor in, then you have a case worth investigating. So this is an example where the LLM itself saw that you deviated from a norm that no human had encoded before. The LLM superpower here is patience. It can look at so many different patterns without ever finding the work boring. And so it's an evolution, but it's an evolution that leads to a step change. We could have done the work ourselves, but would have to spend countless hours to then find out one needle per haystack every week, perhaps worth investigating. Whereas the LLM just kind of does it in the background and pre-sorts that haystack and only gives us the needle. The technical implementation of this and the other two use cases we'll talk about today can use just standard LLMs, even locally hosted ones. Now, the knowledge that the LLM was trained with probably isn't enough to know about normal user behavior, especially not in your network. So you need to expand the knowledge horizon of the LLM by way of augmentation. You're using a technique called RAG, which stands for Retrieval Augmented Generation, which means you're not changing the LLM as such. You're not retraining it, but you give it access to a separate database with the information that's relevant for your use case. It's an easy way to basically leverage existing LLMs into specific use cases without having to build your own LLM or retrain an existing one. So the two core components now to make this use case and the other ones successful are the patience of the LLM and the RAG, so the subject matter expertise that you provide to the LLM as a lookup database to form better opinions, in this case about what a normal user journey through your networks are, to then be able to distinguish any particular case as unusual from that normal behavior. Looking at the second use case that I believe is one of the most powerful ones, again, now the middle of 2025, evolving field, which is source code audits. When going through a large code base, there's just so many things to consider, so many different types of bugs that could pop up in so many different places of the source code. And pen testers and source code auditors have become very good about knowing, based on intuition, where to look. But they're mostly focused on looking for new bugs. That's basically what a source code auditor is supposed to find. Tell you something new about your code base that you didn't already know. Now, sometimes in complex development environments, you are regressing to previous bugs. Source code auditors are encouraged in every iteration of the review to make sure that none of these old bugs have popped up again. Now, that's the less interesting part of the work, right? Because mostly these bugs have disappeared and there's an off chance that they will pop back up. But guess who is more patient? Again, the LLM. So you can make the LLM basically answer the question, have any of the known bug types reappeared anywhere in the code? And there's no claim for completeness here. There's probably a relatively low chance that the LLM finds something completely new, but it's pretty reliable in finding regression cases of bugs. So by training an LLM through the RAG, kind of the extended knowledge base, on the previously discovered bugs, you can make your source code audit flow much more focused on new bugs while the LLM takes care of the regression bugs. Same two success ingredients here, the patience of the LLM and that extended knowledge base of the RAG that includes all the knowledge that you have accumulated about the code base in a way that the LLM can access it. The third cyber use case that I believe is heavily uplifted by AI support, policy audits. What's a policy audit? An auditor takes a list of policy statements, tries to understand them, interprets them in some technical rules, and then does spot checks on whatever is to be audited to see if there are deviations. So for instance, in access control, there could be a policy statement that says a developer is not supposed to commit their own code into production. There always needs to be a separate person, basically 4I principle. I write code, you commit it. Maybe you write code, I help you commit it. But there's always multiple people involved to avoid someone breaking production accidentally or maybe even intentionally. A human auditor reading this statement, probably on a list of dozens of statements, will now have to think about what does that mean in the actual implementation. Okay, I have to look at the access database, I have to look at the different access rights. Some of them will relate to writing code, some of them will relate to committing code. And if I find those two on the same user for the same source code repository, that's a violation of the statement. So there's a lot of thinking and work involved here. And that's why these audits can only happen every quarter, maybe once a year, not nearly as often as we wish for them to happen. Now, who would be able to do them much more regularly, let's say every day? Someone much more patient with infinite time, the LLM. And now training an LLM on, in this case, identity management information, again, through a RAG, through that extended knowledge base, allows for the LLM not just to do spot checks once per quarter, but to review your entire identity management and access management database every day for all of your policy statements. And in the work we've been doing, this has been shockingly successful to basically lead to that step change where before you needed to be extremely careful around setting access rights because there's a chance that it takes an entire quarter for someone to find mistakes, if even then, in a spot checks. Whereas now you can drive a little bit faster because mistakes will be spotted within a day during these daily audits. So the same capability plus patience leads to a step change, which almost feels like a different capability all of a sudden. Real-time checking rather than periodic spot check audits. Patience plus RAG, right? For all three use cases, those were the ingredients that make AI so powerful in driving cyber forward. Now you'll notice that all three of them, though, do require expert level understanding of a subject to start with. Because how are you going to fill this extended database, the RAG, if not with the information from an expert? So these are really tools that help experts become better at their job. They don't necessarily help someone to break into a market with no prior domain knowledge. So if you're afraid of AIs taking away your job, don't be quite yet. But if you're looking forward to being able to focus on less mundane tasks than having to go through logs, go through source code, go through identity management tables, always looking for the same things again and again and again. If you would like for your work to be structured more around where the human brain makes a huge difference, then AIs are a boon by taking away some of that work that requires much more patience than actual analytical capability. This is an evolving topic, so we'll keep updating on the channel as we're encountering more use cases. I'd also love to hear your experience about LLMs, AIs, and how that relates to cyber. Please comment below if you have any feedback, questions, any ideas. If you enjoy the content on the channel, please show it with a like and subscribe, and we'll see you next week. Thank you very much. Happy hacking.